Good morning, friends. Today we'll see in this video about the program for polynomial addition. In the last video we have seen once this particular program. If you want the more explanation of this program, see this video. So here we are creating a node structure. So the node structure is consisting of exponent, coefficient and pointer to the next term. That means this exponent is telling about in the ax power n, the n value is specified by this exponent and the a value is specified by this coefficient. This next is a pointer which is pointing to the next term in the polynomial. So we are taking three linked lists for this purpose. The first linked list is used for representing the polynomial 1 and the second linked list is used by representing with the start 2. And the third polynomial P3 is represented by using the start 3. That is start 1, start 2 and start 3 are the three starts of the three linked list that we have taken. The source of this linked list is, the source of this polynomial addition is start 1 and start 2. And the destination for this start 3 is the polynomial 3. That means start 1 is added to the start 2 and the resultant is stored in start 3. Now for every polynomial before reading we will see how to display this particular polynomial. Displaying of the polynomial is nothing but displaying of the single linked list that we are having. So in this display function we are taking the start as the starting of the linked list and we are considering the PTR as a pointer. So initially when we want to display any linked list, the pointer is starting at the start node until the pointer is not equivalent to null. That is, even the last node has to be printed. If the pointer is not equivalent to null, I am displaying that in the form of a power n. So that means I am displaying this in the particular format of the coefficient and the exponent that we are displaying. After displaying one term, the pointer is going to the next term. This process is repeated while the pointer is not equivalent to null. Whenever the pointer is equivalent to null, we are coming out of this particular loop. That means all the nodes in the linked list or polynomial are displayed. Next function that we are going to see is add node. What is the purpose of this particular function? So in the previous example that we have seen, when we are adding 8x power 11 and 7x power 11, we have to get the result as 15x power 11. That means I have to add one term to the third polynomial. That means I have to create a node that is consisting of 15x power 11. That means 15 as a coefficient and 11 as an exponent. So for that particular purpose, we are taking that I want to add a node to the resultant polynomial that is having the exponent as n and coefficient as c. So for that particular purpose, we are taking the new node. That is, we are creating the new node and we are taking the pointer. So initially I am creating the new node by using the struct node star mlog size of struct node. So after creating this particular node, the exponent of this node is n and the coefficient of this node is c. So that's why new node of exponent is equivalent to n and the new node of coefficient is equivalent to c. Because this is the single term that I am creating, new node of the next is made as a null. Now where to add this particular node? So generally when the polynomial is represented in the descending order, so whatever the new term that is coming, the new term has to be added to the end of the polynomial. For that particular purpose, we are seeing whether the polynomial is empty or some nodes are present. If the polynomial is empty, the start is equivalent to null. Then our node will become as the starting node of the resultant polynomial. Otherwise, I have to go to the end of the polynomial. That we are doing by using pointer equal to start, while pointer of next not equivalent to null, pointer equal to pointer of next. This code will bring the pointer to the last node. For that last node, I am attaching this new node. That is, by using the pointer of next equal to new node, I am attaching and I am returning the start. That is, every time when we are adding the two nodes and the resultant is placed into this particular third polynomial, this function is used. And not only for that purpose, This function is also used to create a new polynomial. Now we'll see the create polynomial. Actually, before addition of the two polynomials, I have to create the polynomials. As an example, in the previous example, we have taken the two polynomials. We have to create at first the two polynomials. For that particular purpose, I am taking the create polynomial function. Here also, until you tell no, I am going to add the terms for this one. So please see that you are going to add the terms in the descending order only. So we are taking the C and E. C is for the coefficient and E is for the exponent. At first I am placing this in the do while loop and I am reading what is the coefficient and what is the exponent. I am reading ampersand C and ampersand E and I am adding the node to this particular start. That means I am creating one node and I am adding that to the start. So I am asking, do you want to enter more terms? If you are entering yes, once again this will be repeated. Like 8x power 11 you have taken. Next some 5x power 4 you are taking. Some 3x square you are taking. Like that until you are entering y for this particular thing, this loop will be continued. Once you are pressing other than the y, it will be coming out of this particular loop and it will be displaying that particular linked list, that is polynomial what you have entered to know to us, and we are returning that particular start. Like this, in the main function I am going to create the polynomial 1, that is by using the start 1, and I am going to create the polynomial 2 by using the start 2. So this is the function that is used to create the polynomials, and this is the function that is used to add in resultant node to the polynomial. Now we'll see the original activity that we are having for addition of the two polynomials. Now I am taking the polynomial 1 is pointed by the start 1 and the polynomial 2 is pointed by the start 2. And the resultant polynomial is the start 3. That's why the input for the addition of the polynomial function is start 1, start 2 and start 3 pointers. Start 1 and start 2 for pointing those things. In the examples, we have taken the P1, P2 pointers. Now P1 pointer is pointing to the start 1 and P2 pointer is starting to the start 2. And the addition of the polynomial function is performed until both the nodes are not equivalent to null. That means I am going to repeat the case 1, case 2, case 3, what we have seen in the previous examples. I am going to perform these three cases until the two polynomials are not equivalent to the null, that is until the end of the two polynomials. So case 1, if you see, what is the case 1 that we have seen? The case 1 that we have seen is polynomial 1 exponent is equivalent to the polynomial 2 exponent. What we have done when the polynomial 1 exponent is equivalent to the polynomial 2 exponent, when polynomial 1 exponent is equivalent to the polynomial 2 exponent, the activities that I have performed is polynomial 1 coefficient is added to the polynomial 2 coefficient and the resultant is placed in the polynomial 3 coefficient. And the exponent what we have considered is either polynomial 1 exponent or polynomial 2 exponent has been placed. And because these two terms are over, and P1 is incremented to the next term and P2 is incremented to the next term. The same activity that I am performing here. When polynomial 1 exponent is equivalent to the polynomial 2 exponent, I am finding out the sum, that is polynomial 1 coefficient plus polynomial 2 coefficient, and I am adding that as a coefficient of the third polynomial term. And the exponent that I am considering is polynomial 1 exponent. That means for the third polynomial I am adding polynomial 1 coefficient plus polynomial 2 coefficient as a coefficient and polynomial 1 exponent as an exponent. Because the two terms were over, polynomial 1 is incremented to the next term and polynomial 2 is incremented to the next term. This is the case 1 that we have seen. Next we will see the case 2. What is this case 2? Polynomial 1 exponent is less than the polynomial 2 exponent. So whenever the polynomial 1 exponent is less than polynomial 2 exponent, suppose polynomial 1 exponent we have taken in the example, previous example we will see once again. So polynomial 1 exponent is 3, polynomial 2 exponent is 4. Polynomial 1 exponent is less than polynomial 2 exponent. In such case, this 5x power 4 is added to the resultant. The same thing that we are doing here. Whenever the polynomial 1 exponent is less than polynomial 2 exponent, what I am doing? I am creating a node in such a manner that the resultant is polynomial 2 coefficient and polynomial 2 exponent, whichever the term that is highest that I am going to add. Here the polynomial 2 term is highest, that I am adding to the start 3. Because the polynomial 2 term was over, I am going to the next one. Now the third one. The third one is polynomial 1 exponent is greater than polynomial 2 exponent. Polynomial 1 exponent is greater than polynomial 2 exponent. If you see this one, this is the example that we have taken. Polynomial 1 exponent is 2 and polynomial 2 exponent is 0. Polynomial 1 exponent is greater. In such case, whichever the greater value that we have to place. So that's why I am adding polynomial 1 coefficient and polynomial 1 exponent to the third polynomial. And the polynomial 1 is incremented to the next term. These are the three cases that we have seen. And the fourth case that we are having for this one is, if one polynomial was over, we have to add the remaining terms of the second polynomial to the third polynomial. Example, if polynomial 1 is equivalent to null, the meaning of this one is polynomial 1 is over, but polynomial 2 has not been over. The additional terms that are present in the polynomial 2 has to be added to the third polynomial. That's why we are taking until the P2 is not equivalent to the null. That is, whenever the P2 is equivalent to null, you are going to come out. Whenever the P2 is not equivalent to null, I am adding that P2 term, that is P2 exponent, P2 coefficient to the start 3, and P2 is going to the next term. Like this, until the P2 is equivalent to the null, I am going to add all the terms of the second polynomial to the third polynomial. This we have seen in the example. So because if you see, P1 is null and P2 is not null. In such case, whatever the terms that we are having for the P2, the terms are added to the P3. The same case we are repeating the P2 polynomial. If P2 is equivalent to null, that is P2 polynomial was over, but P1 polynomial has not been over. In such case, what we will be doing? The same thing. The P1 polynomial terms are added to the third polynomial until the P1 is becoming null. And I am displaying at the end the third polynomial after performing these three results. That means the addition of the two polynomials is displayed. So this is the way in which the four cases have been implemented. What are the four cases? When the polynomial 1 exponent is equivalent to the polynomial 2 exponent, I am adding the result as polynomial 1 exponent and polynomial 1 coefficient plus polynomial 2 coefficient. The second case that we have seen was polynomial 1 exponent is less than the polynomial 2 exponent. In such case, whichever the largest that I have to add. That means I have added polynomial 2 exponent and polynomial 2 coefficient to the resultant. And the third case, if the polynomial 1 exponent is greater than polynomial 2 exponent. In such case, the polynomial 1 exponent and the polynomial 1 coefficient are added to the resultant. The fourth case, it is two parts. If the first polynomial was over, I am adding all the terms of the second polynomial to the result. The second part of the fourth case is, if polynomial 2 was over, whatever the terms that are present in the polynomial 1, those terms are added to the resultant. These are the four cases that we are having. After completion of that four cases, I am displaying the resultant polynomial by using the display function. This is the function that is adding the two polynomials. And the driver program for this one is main function. See here, I am creating the start one. Start one is I am creating the first polynomial. Start 2, by using the create polynomial function, I am creating the second polynomial. And I am adding the start 1 and start 2. That means polynomial 1 and polynomial 2. And the result is placed into the polynomial 3 and it is returned. In the add polynomial itself, I have called the display function. So whatever the resultant that we are having, that will be displaying of this polynomial. I'll be attaching this program with this presentation so that you can run that program and you can see how the output will be coming for this one. Thank you.